Okay, so first of all, quiz number 1 was last week. It was called an assessment quiz. Quiz number 2 is this week. And we're gonna go ahead and take a look at it for a second. Like I'll show you where it is. And I'm also gonna show you where the homework is because I had a few questions about your first and second homework. So due on the same Tuesday. And just a reminder that you don't have to submit your homework. Once you're given credit on a problem, that score is recorded. So there's no button you have to push to get points. The website records your points for you. One more thing is that I need to change my office hour. Instead of Monday, Wednesday, I'm going to do Wednesday, Friday. With the same meeting ID and the same time. And just a side note, it's been a little bit busy the last 2 weeks with school starting. I'm catching up on giving people more time on assignments because I know that everybody's kind of getting used to their classes and all the things to do. So if I haven't given you an extension, I'll work on that as soon as I can. And catching up on emails and everything like that. Okay, so I would like to show you where your assignments are and then do some notes. Okay, there we go. I should have gotten this ready here. I just need student view and we're good to go. Okay. Okay, so this is our Canvas page. And the homepage is the modules. I will have a module for every week of the semester, and there will be your meetings and sometimes the quizzes or an exam. And in your assignments, you can also find quizzes. And what these homeworks are placeholders so that I can put your scores in from XYZ and we can know what your overall grade is. But you can't get to the homework through Canvas. You have to go through it separately at xyzhomework.com. So again, soon I'll update your gradebook and you'll have more scores. Oops, that's not like that. I don't know what that looks like, but we don't want to look at anyone's grades just in case. Okay, and I'm going to change the syllabus so that the new office hour is there, but if you ever need to check out the syllabus, it's posted with instructions for how to get to XYZ homework. And you can also find the quizzes and exams under quizzes. So here's quiz number 2. It's 5 questions. You have a week to get it done and there's no time limit. I didn't see a save for later option, so I think you have to do it in one sitting, but you can redo it as many times as you want to. Okay, so give me just a moment. I'd also like to show everyone the homework website one more time. Okay, let's do this together. This is what the homepage looks like. If you've never been here before, you'll need to register as a new student with that button below the login. But I've already made an account, so I can log in. And well, this is my account as a teacher, but in your homework, you should have a calendar. To get to an assignment, you have to click the icon. So if you want to do homework 2, you have to tap homework 2, and then this little link comes up where you can reach the problems. And this second homework has 28 problems. So you'd have to do all of those to get, full credit. There is a message section. So if you need more time on homework, or if you have a homework question, you can write to me through this website. All right, I think we're good to go. Last note is that the ebook is below your calendar, and I like to look at the book sometimes for extra examples. So I think we're in chapter 1 right now. We went through chapter 0. Let's check it out. One more thing as we're looking at this, sometimes as you go to a new chapter, it will make you log in again with your XYZ username and ID. But once you redo your login, you can keep on looking at the book. So we're finished review. We're in chapter 1, and let's see, I think maybe a little bit of chapter 2. Yeah, we're in chapters 1 and 2 right now. Okay, let's go on to notes. Oh, questions. Yeah, let's do questions. Oh, for XYZ, I'll share the course ID. Let's get that up. Just in case anyone else needs the ID, I'm going to share. All right, I think we're good to go. As always, look out for mistakes or stop me if you have a question. And if we don't finish these notes, we can always come back next week and keep practicing. All right. So we left off with how to clear fractions from an equation so that you can solve for whatever variable that you're looking for. Let's do a cool title. If you'd like to just sit and follow along, that's fine, but I encourage you to take notes. It helps so that when you go to do your homework, you have problems already written out. You don't have to rewatch a video or go to a tutor. But soon I will share that info about tutors at Sac State. Soon as I can. So what you can do is multiply both sides of the equation by the LCD. Before we continue, I want to answer the question about homework. So the purchase should be of $45 and it gives you access for 1 year to any other classes that you have on XYZ. So you have a free trial for 15 days. And after that, I think, and I'm going to check because I've made my own student account. But after the free trial, then you have to pay to continue to access your homework. And that access was again $45. Thank you. I just want to share that with everyone because you know, did a 15-day free trial. Then you need to put in $45 to continue to have access. Alrighty, let's go back to trying an example. We're going to look at x over 10 minus 2 equal to 2/5 x plus 3/7. Okay, so we're going to get the LCD from every fraction in the equation. So we're going to factor the first denominator. It's 2 times 5. If you want to write this as a fraction, the denominator could be 1, because any number over 1 is still the same number. But next, we're going to look at 5, which is factored. 7 is factored. So out of all of those factors, I know we're going to use 5. 5 shows up once. There it's only one time. So you just need 1 5. It's the most of your factor from any of those denominators. There's a factor of 2, which means it needs to be in the LCD. And then your factor of 7. So we're going to multiply 70 with the left and right side of the equation. Distribute 70 on both sides. Right here. 70 times x over 10. The 70 over 10 is going to reduce to 7. 70 times negative 2 is negative 140. let's do 70 and then divide by 5. So there's 14 left over. 14 times 2, 28x. Here, the 70 times 3/7. 70 over 7 is going to reduce to 10. And then you have 10 times 3. Which is 30. What we want to do is get the x values together, get the number values together. Let's start with subtracting 7x from both sides. So negative 140 equal to 21x. So I'm going to subtract 30 from both sides of the equation. It's negative 140 minus 30, which means you're going even further negative to 170. Here we have 21x. Okay, we're going to divide both sides by 21, and that way we have solved for x. But I think we're going to need to simplify that answer. Let's check it out. Okay, I can write 170 as 10 times 17. And 21 is 3 times 7. And then let's factor 10 into 2 times 5. And 17 is prime. So there are no common factors, which makes this a fully simplified fraction. Okay, next one is x over 2 plus 1 over 4. And it's equal to x over 3 plus 1 over 6. Okay, on the side, I'm going to find the LCD. And it's from every fraction in your equation. So factor all of the denominators. 2 is already factored. 4 is 2 times 2. 3 is factored. 6 is 2 times 3. Okay, let's start with the factor of 2. There's 1, 2. Here's 2 2's. 1, 2. So you go to the most of your factor, where you have 2 2's. Okay, we also need to include that factor of 3, which happens one time here and one time here. So you just need it one time. I need to multiply, or if I multiply both sides by 12, then it will get rid of all of the fractions. And you're going to distribute 12 to both of those terms. We're going to do the same thing on this side. All right. 12 over 2x. 12x over 2 is going to leave 6x. 12 divided by 4 is 3. 12 divided by 3 is 4. And then 12 over 6 is 2. All the fractions are gone, and I want to get the x values together and then the number values together. Let's start with subtracting 4x from both sides. 2x plus 3 equal to 2. Let's just copy down what's going on. And after that, I think I want to subtract 3 from both sides. So then 2x equals negative 1. Then we want to isolate x by dividing both sides by 2. So arrow means then, so then x equals negative 1/2. We should check our answer. I think I'm going to skip checking, but if you have time, check your answer. Okay, let's do something kind of similar but different, where we're going to talk about how to clear decimals. You multiply by some power of 10. So 10 or 100 or 1,000 or 10 to the 5th, depending on how many decimal places you have. Oops. We have 0.5 plus 0.2x equal to 1.4 and subtract 0.7x. Okay, I don't really feel like working with all the decimals. I could if I wanted to, but I'm going to multiply by a power of 10. And here's one decimal place, just one spot. So I'm going to use 10 to the first. Just multiply both sides by 10. Distribute 10. So 10 times 0.5, then add 10 times 0.2x. So there's that decimal place over 1 to the right. Same here, 10 times 0.2 is 2. Do the same thing on that side. So when we multiply by 10, it moves this decimal place one spot over. Here, this is minus 7. All right, we're trying to solve for x, which means we need to isolate x. Get the x values together by subtracting 2 from each side of your equation. You've got 5, and this 14x, and then minus 2x is 12x. And I will add 7 to both sides. Where are we at? So 12 equal to, right? Let's see. Yeah, 12. We can check it afterwards. It looks weird to me, but 12 on this side and then 12x on that side. You want to divide those sides by 12. And we'll have 1 equal to x. And I would like to check this one, just in case. So back to the beginning of the problem. I had 0.5 plus 0.2. I'm going to put in 1. Oh, that's kind of cool. It looks weird, but it's cool. On this side, so 1.4 minus 0.7 times 1. Okay. So we're going to leave the equal sign, and we don't need to add or subtract anything. We just want to put those numbers together, put these numbers together, see what happens. So 0.5 plus 0.2. On the other side, 1.4 minus 0.7. Got 0.7. And just to be sure, it should be 0.7 here, but never hurts to do some scratch work. I would need to take away from here, put that there. That's a 7. Bring down your decimal place, and that's a 0. Okay. This was true. That's a solution. All right, we're going to keep on working with decimals. And this time it's 0.03x minus 0.12 equal to 1 plus 0.05x. So you want to look at how many decimal places you have. This one has 2 places. Here's 2 spots, 2 spots. And I would multiply both sides by 10 squared, which is 100. Distribute 100, which will move that decimal place over to the right 2 spots. So I've got 3x. Same here, 100 times negative 0.12. We're going to move that decimal spot over twice to the right and subtract 12. 1 times 100 will be 100. And then 100 times 0.05, it moves your decimal over to the right 2 times. And then it's 5x. I can subtract 3x from both sides. And then I will subtract 100 from each side of the equation. We're going to have to continue. All right, so a negative 12 and then minus 100 is even further negative over to negative 112. And on the other side is 2x. Divide both sides by 2. And here to here over there is, let's factor this. Let's see, negative 112. Oh, okay, it's cool. I have something different in my notes, but we're just going to keep on figuring this out together. Let's divide it by 2 somewhere. 2 goes into 11 5 times. 5 times 2 is 10. And then 11 minus 10 is going to leave 1 left over, bring down that 2. And 2 times 6 is going to be 12. And that's 0 remainder. So don't forget that negative sign. And then we're going to factor 112 into 2 times 56. And it's over 2. And on the other side, I've got x. Okay. 2 over 2 reduces to 1. And then 1 times 56 is 56. And still, you have that minus sign out front. We should check it, but I want to just keep on doing examples. So I'm going to put it in a bubble, but if you have time, I would double check. So we've gone over how to clear fractions and how to clear decimals. I'm going to do some random examples until we get to solving equations with more than one variable. It's negative 2/3 times 5x plus 1/2. And it's equal to 0. So what we want to do is take that whole value of negative 2/3, and this is just one way to solve the problem, is to distribute it to both of the terms inside of your parentheses. It's negative 10/3 x minus 2 times 1 is 2, 3 times 2 is 6. Let's see. I can multiply both sides by the LCD, which I think I'm just going to go ahead and jump to that step. Instead of trying to simplify this, let's just multiply both sides by 6. So this 6/3 reduces to 2, and then 2 times 10 will have negative 20x right there. When you take this number here and then all the way over to there, 6 times negative 2/6, the 6/6 reduces to 1, and then there's negative 2 left over. And 0 times 6 is still 0. How about we add 20x to both sides? We don't need that. So negative 2 equal to 20x. Divide both sides by 20. I'm going to get rid of all that. Okay, negative 2/20, which I'm going to factor, is 2 times 10. And on the other side, 20/20 is 1. 1 times x is x. And 2/2, we've been saying any number over itself is 1. So negative 1/10 is equal to x. Okay, we're doing really good on time. So I have a new variable, but it's just one variable where we're going to solve for W. The equation is 2 plus W is equal to, in parentheses, 4W minus 3. Times 1/5. Okay, so it's kind of like the last problem, but instead of having that step where we distribute the 1/5, I'm just going to go ahead and get rid of that fraction right there. So let's multiply both sides by 5. And if you're going to affect one side of the equation, you have to do the same thing to the other side of the equation. So that way that's how they can stay equal to each other. Do the same thing to both sides. All right. So let's go over on the right side. I did that so that the 5 can cancel with the 5, and the 4W minus 3 is still there. On this side, you distribute 5 times 2 plus 5 times W. And let's subtract 4W from each side. 5W minus 4W is 1W. Then this is a 0W and then a minus 3. I think if we just subtract 10 from each side, then we'll have solved for W. If I had time, which I kind of want to make sure we get through all our notes, I would check my answer, but I'm pretty sure that's correct. Okay, let's do one more and then move on. Okay, the variable is t, which means if you're solving for t, it needs to be isolated to one side of your equation. It's 2 times t minus 1. Minus the quantity of 5 minus t. It's equal to 7 plus t. Okay, so take care of all those parentheses by distributing the value that is being multiplied with. So this 2 multiplies here and here. That negative, it's technically a -1. -1 multiplied with 5 and that negative t. Give us 2t minus 2 minus 5 plus t and an equal to 7 plus t. So you combine all of the like terms, which you're going to put the t values together. And then we'll get these negative numbers together. See what happens after that. 2t plus 1t is 3t. Negative 2 minus 5 is negative 7. And then there's a positive 7 plus t. And I've seen a lot of mistakes happen when you see the same number on both sides. I suggest that you still do scratch work and make sure you don't just jump to the solution. Let's continue making sure that we follow all the right rules and get the right answer. Okay, if I have 3t minus 7 equals 7 plus t, I would subtract t from each side. 3t minus t is 2t minus 7 equal to 7. So you want to isolate t, which means add 7 to both sides. All right, 2t equal to 14. Then divide each side by 2. And we have solves for t, and t is equal to 7. Okay, so we're going to look at equations that have more than one variable, and I have steps for how to solve those equations. Okay, so it's kind of like the other problems we were doing, where if you have parentheses, use the distributive property if needed. So use distribution if needed. And also, depending on the problem, you want to combine like terms. Then you get the variable you're solving for on one side of the equation. And then all other values on the other side of your equation, which I'm not going to write, it's just a bit too wordy. Okay, well, we're going to put that you're going to do step 2 using addition or subtraction. And then the last step is to isolate the variable using multiplication or division. The equation is going to ask us to solve for x. The question is to solve for x. And here we go. A over x at b over x, and it's equal to 8. I don't need distribution, but I do want to combine like terms. So we're going to put this together. It's a plus b over x. And then I don't need to go over any addition or subtraction right now. I just want to go to the last step and use multiplication. Multiply both sides by x. That way I can get that x out of the denominator. Okay, let's keep going, but now I'm thinking I have a side note to tell you later. So a plus b equal to 2x. And then isolate x by dividing both sides by 2. So just kind of thinking that I'll try to write it. I'll try to write it for the next week's notes. But when you want to solve for a variable, it needs to not be in a denominator, and not have any other values attached to it. You need just that, I guess, variable sitting by itself. I'll find a better way to say that next week. Okay, let's try another one. We're going to take 2x minus y plus 3x. Maybe back up a little bit. This expression equal to 7x plus y. And then solve Combine like terms. The 2x is going to go with the positive 3x. I'll have 5x minus y equal to 7x plus y. So you want to get the variable that you're looking for, x. You want one value of that variable. So we need all values of x on one side of the equation, everything else on the other side. So let's do minus 5x to both sides. Negative y equal to 2x plus y. And again, I just almost kind of saw it myself, is be careful when you see this matching number to still do scratch work, because you don't want to make any mistakes. I want to get x by itself by subtracting y from each side. And then negative 2y is equal to 2x. The goal is to isolate x, so divide both sides by 2. And that way you have gotten x on one side of your equation and a negative 1 on the other side. Alrighty, I think let's see. Do some more examples. Okay, the next one has z equal to, we're going to solve z equals x minus 2 over 5 for x. And if you're going to take a stats class next semester, you're going to see something like this a lot when you get into standardizing a variable, which your stats teacher will teach you about. Okay. Which, by the way, hopefully I'll teach stats next semester and you can take my class. Multiply both sides by 5. So the goal was to have the 5's cancel and I get rid of the fractions in the equation. And over here, there's a 5z and it equals x minus 2. And then add 2 to each side. Okay, I've solved for x by getting that variable on its own and everything else on the other side of the equation. That's good. Okay, one more, and then we're going to move over to talking about percents. going to solve for B. When A plus 2B is equal to C over 5. So the goal is to isolate B. Start by subtracting A from each side. So we could either we can divide both sides by 2, or what looks a little bit better to me is to multiply by both sides by 1/2, which is the same idea. It's just a different way of looking at it. So I'm trying to get B by itself. So I need to take care of that factor of 2. I will multiply by 1/2 on both sides. And I did that to get those 2's to cancel, or to have 2 over 2 reduced to 1. And then the graph 1 times B is B. And I'll get B equal to 1/2 times C over 5, which is C over 10. Minus A over 2. I feel like that's good enough. I could put these 2 terms together by getting a common denominator, but I really just wanted to solve for B by isolating it. Okay, I want to talk about percents. So a percent is a proportion out of 100. We have talked about this before, but just in case, we'll do one quick example and then ask questions like you'll see on homework 2. Let's just put 12 over 100 is 12%. Okay, so what is 30% of 84? Just a second. Okay, so I think next week, we're probably going to run out of time today. We're going to work on translating English statements to math statements, to from English to math. Of means multiply. So if you see of, you multiply. So what is 30% multiplied with 84? 30% times 84. Rewrite 30% as 30 over 100. Or let's see. And then I just used a calculator or used some scratch work, and I got 25.2. So I guess the goal really is just to be translating this question and then, simplifying your answer. Another one where we ask, what is 19% of 28? So take 19%, multiply with 28, and then simplify. %, would be 19 over 100. Multiply that with 28. And again, you could do some scratch work or use a calculator. I mean, we all have a calculator usually on our phone. And I got 5.32. Okay, we want to ask, what % of 46 is 23? Uh-oh, and I think we're out of time. I think I can finish this question at least, and then we'll come back, do a couple more % questions. Then we need to translate English to math. And, I have a little bit of notes about perimeter, and then I think that's that. Again, we can finish on Tuesday. This question, what % of 46 is? We want to talk about this being multiply. Is means equals. And we'll set up the problem. So what %? We don't know what that is. We need to say something unknown. We'll call it X. Some percentage times 46 equals 23. Solve both sides. Solve for X by yikes. Solve for X by dividing both sides by 46. X equal to 23 over 46 is 0.5. Multiply by 100 over 100. If I have 100 in the denominator, I can write this as a percent. It's 25 times 100 moves the decimal place over 2 times to the right. And then 50% is my answer. Okay, so that's good enough for today. We'll finish notes for homework 2 on Tuesday. And if you have any questions about the homework, of course, we can go over those in class. All right, we're done.
Thank you.
Yeah, thank you.